Hello everybody, today I'm going to do a quick overview of what it means to complete the square. So to begin, I have two problems down here that we're going to look at, remembering the idea that a quadratic in standard form is ax squared plus bx plus c. So the directions say state the c value that would make each expression be a perfect square trinomial. Remember, a perfect square trinomial is a trinomial where the first and last terms are perfect squares. So pause this video and think about what your answers could be for each one of these. Okay, so in looking at this, hopefully the realization here is that you notice that you had a 6 in the middle, which we know that a 6 is 3 plus 3. And in order for this to be a perfect square, it would have to be a number times itself. So 3 times 3, which would be 9. So let's look at this problem a little bit differently using Algebra Tiles. So what we had is we had x squared and we had 6x. So we had 6 of these. So we had 1x squared and we have 6 x's. Now the idea is to take these and create a square. So this is a square, but we want these to be included as part of our square as well. So in order to make a square, that means that the dimension would have to be the same for the length and the width. So I don't want to put this here, because then if I start putting these down here, it's not going to, there's no way to, that would end up being a rectangle if we were to fill this in. So in order to make it a square, you have to take those x values and you have to divide them in half, which is dividing by 2. So if we have 6 x's and we divide it by 2, we get 3. Now this isn't quite a square yet. We have some more that we need to fill in. So we're going to fill it in with these 1 tiles. We call them a unit tile because they each represent 1 unit. And I'm going to keep filling this in until I get a square. So I'm almost there. There's 8. And there's 9. So in order to make this a square, I had to add 9 unit squares to make it a square, creating what we call a perfect square. So this is another representation of a perfect square trinomial. The length of this is a length of x. Each of these lengths is plus 3. So that gives you x plus 3. The length of this is x. And then the length of these is each 3. So that's another x plus 3, which gives us x squared plus 6x plus 9, 9 being our new c that we came up with in our problem here. So by creating a perfect square trinomial, we are able then to take that and factor it. Remember, a perfect square trinomial will always factor into 2 binomials that are exactly the same. And we're looking for 2 numbers here that give us a product of 9, so that would be 3 times 3. So remember, they have to be the same, and we always write it as a binomial to the second power. Okay, so look at the second one. What did you get for the second one? Hopefully you got 49. So again, -7 plus -7 would give me -14 if I add it. But if I multiply a -7 and a -7, I get a positive 49. So factoring that, that would be an x minus 7 times x minus 7, giving you x minus 7 to the second power. I know I didn't tell you to factor it, but I'm just trying to remind you of what a perfect square trinomial looks like when you factor it. So let's talk about this completing the square. Now I've talked about it with Algebra Tiles. So the idea of completing the square is the idea of making that expression a perfect square trinomial. So with the Algebra Tiles, what I had to do was I had to add 9. And what I did to get that is I took that value of 6 and I divided it by 2. Remember, divided it into 2 parts, gave me 3. And if I square that number, I will get this value here. So that's exactly what we're going to do to complete the square. So the idea of completing the square is this idea of adding a c value to a binomial or an expression that is 2 terms to create a perfect square trinomial. Okay, so we're taking something that is in the form of like ax squared plus bx, and what we're doing with that is we're adding a c value to it so that whenever we factor it, it will factor into a binomial squared. Okay, so that's the idea here. Okay, and again, the way that I did that, the way that I got this value, if you think about the algebra tiles, is I took that value of b, remember it was 6, and I split it up into 2s. Split it up into 2 groups. So I took the value of b, which ours happened to be 6, and I divided it by 2. And then to get the 9, I squared it. So again, if you think about this one up here, I took the value of 6, split it in half to give me 3, and then in order to get a perfect square, I squared the 3 to get 9. So this is your formula, I guess you could call it. So this is what we could call a formula of some sorts to get your C value. Right? It's not like a formal formula, but it's a process that we can take to get that, which this process can often be done in your head. Okay, so let's look at a couple more examples here. So if I have x squared minus 8x, what would I add to it to make it a perfect square trinomial? So the way that I would do that is I would take my value of b of negative 8, divide it by 2, and then I would square it. So that would give me a negative 4 squared, and you can see that's going to give you a positive 16. So when you complete the square for this problem here, it's going to be x squared minus 8x plus 16. Now, if we were to factor it, it would factor into 2 binomials that are exactly the same, which would be a binomial to the second power. So you know it's going to be x and x. And the way that we get negative 8 and 16 would be negative 4. Okay, so just to show you what it would look like if you complete the square and if you factor it. When you're doing this problem here, we can see that if we go to divide that value of b by 2, we're not going to get a whole number. We're going to get a fraction or a decimal. So if I take my value of b and I divide it by 2, I get 9 over 2, or 4.5. But I'm going to leave it as a fraction because it's easier to square a fraction than it is a decimal. If I square that, I get 81 over 4. So if I complete the square, I get x squared plus 9x plus 81 over 4. 81 over 4 is a perfect square. It's 9 halves times 9 halves. So if you go to factor this, remember it's going to be 2 binomials that are exactly the same, or that binomial squared. In this case, it'll be x times x. These are all plus signs, so it's going to be a plus sign. And you have to think about, what do I multiply to itself to get 81 over 4? Well, that would be 9 over 2. If you notice, another pattern that we can see here is that this value right here in the parenthesis, that's the value of b over 2. So this is just another pattern to recognize, okay? So you'll be using this process later on to solve problems by completing the square. So you'll get a little bit of practice with this today, and best of luck with that.